just quickly tell you a little bit about myself and how I got here, and hopefully this is going to be useful and interesting to all of you. I'm looking forward to discussion, not just a one-way monologue, so please ask questions. So probably 17, 18 years ago, a while ago, I was working at here in Atlanta at Turner Broadcasting, and I was looking for something different. And long story short, I ended up going to a company called Gigaspaces. I don't know if anybody's heard of it. It was like one of the early in-memory data grid companies. Okay, and I've been working for in-memory data grid type companies since then, and in either a consultant role or a solution architect role, and doing a lot of work with their in-memory data grid customers. So I come at this event-driven thing from a little bit of a funny angle. But what happened probably close to 10 years ago now is I started to I had a couple of customers that actually built event-driven event processing systems. Like, I have trucks and I need to know where they are and I need to compute their, I need to do things with the telemetry off the truck, things like that. So they started to build these systems a good 10 years ago. And I started to think, wow, it would be cool to build an event processing system on top of an in-memory data grid, which is kind of a funny angle to come at it from. But that's the angle I come at it from. And Hazelcast, and so I've worked for a number of vendors. Hazelcast actually did build an event processing system on top of an in-memory data grid. That's how I ended up there. So recently, I've been kind of hearing this buzzword about event-driven microservices. Is it really a different architecture? Is it that important? If you do a little research or you've Googled on it, you'll see that there's like an O'Reilly book on it, and you'll see, not too surprisingly, that Confluent has a white paper on it. So I started to think, yeah, there's something here. And so there's this kind of body of work that architects have done around the new tooling that we have, the new capabilities that we have, primarily Kafka and things like Kafka, like Red Panda. So, is it a thing? Yeah, I think it's a real thing. I'm going to present it like in a kind of a pure form, just for simplicity. Do I think that everybody should now just go out and only do event-driven architecture and event-driven microservices? No, I don't. There's no replacement for judgment, so I just wanted to, but I'll probably present it that way because it makes it a little bit easier if I don't muddy the waters. So with that caveat, let's jump in. I'll set my timer here so I know how long I've been. All right, so what are event-driven microservices? Well, they're just microservices that follow event-driven architecture principles. Okay, that's not a lot of information, but what is a microservice? So I want to spend a little time on this, just to level set. And at least for me, microservices connote like this transformation. This whole idea. It's not just a architecture, but it's this journey of kind of decomposing a monolith. I'll say it into individual parts or individual services. So it's a way of doing that. And why do you do it? It's definitely not for simplicity. So the reason that companies do it, in my opinion, is for agility. So any architecture that that we're going to call a microservice architecture has to promote agility. So agility has become more important. Companies are willing to accept some complexity in order to like be able to be faster to market. And why was there a need for a change? And I think I don't know if I've actually been around long enough to actually work in some of these environments, but if you have we'll go into this more in shortly, but if you have a single, a bunch of applications pointed at a database, that the database becomes your interface, and it's not a very well-defined interface. And what happens is that it becomes very, very easy and even unpredictable for one app to influence another app, and then via the database or via database schema changes, and then inevitably some kind of change control gets enacted, and that's where things become slow. So basically, this microservice trend that I think is pretty well established now is basically undoing that. So basically, these services get their own technology stacks, they get their own teams, they get their own databases, which surely brings problems. But anyway, so what is a service? So it's a small unit. It's organized around a business function. This is just my definition. I think I'm curious to hear if you think I missed anything or added too much. Independently deployable. I think that's the important part from the agility point of view, right? You have to be able to deploy this service and not affect that service. Composable but loosely coupled, and importantly, built by small autonomous teams. That's how we get the agility. So an event-driven microservice architecture also needs to meet these criteria, or we won't. The whole reason for doing it's going to be more complex. So we gotta make sure we get the that's the cost. We gotta make sure we get the benefit. Okay, so what's not necessarily in that definition, in my opinion? So just request response, REST, application servers, all the usual stuff you think of. Those are the means to the ends, but they're not microservices. They just using REST won't get you those things on that last slide, right? It's really more of an architecture. So, all right. So now, does a microservice have to be request response? What do you think? Yeah, of course. Yeah, right.
Yeah, but if you don't request and response, you won't be able to overlook their message logic. Yeah, I feel that way.
Okay. So I have some examples, and you could probably think of some other ones. But so I would claim no, it doesn't have to be request response. And I'm not really talking technically, I'm just talking logically at this point. So status updates, like when the pizza is out for delivery, yeah, you could have your phone, you can have an app on your phone constantly polling some status API. Is it ready? Is it ready? Is it ready? But for one, it's going to burn the battery up, but it's not a great architecture. It's just more naturally a notification, right? Some things just are notifications, or more naturally modeled as notifications. Telling the customer their parking is about to expire, things like that. How about business process orchestration? Like, basically when a customer places an order, make a plan for fulfillment, dispatch pick orders to various distribution centers. So it's not something you would ever just sit and wait for, right? It's an orchestration, yet it's still a service, right? It's still a chunk of business logic that you ideally would like to be able to pull out and replace, right? Pull out and evolve independently. So I think part of this idea is the idea that that microservices aren't just things aren't just requests. Some of them are they're just reusable chunks of business logic. Some of them are more naturally modeled as events. Okay. All right, so here's really the meat of it then. What are the principles of event-driven architecture, in my opinion? Okay. All right, and I've got, what is it, 1, 2, 3, 4. Let's talk about each of these. I've got 5 of them. Okay, so first difference, it's a pretty big difference, is APIs define the communication versus events. So the interface in a microservice, a REST microservice, for example, the interface is, it's an API. It's something that we're all familiar with that looks like on the traditional microservice side. And in event-driven architecture, the interface is just, here's this event. Here's all the fields that are in it. Here's what it means. I'm going to publish this event. I'm going to tell you that this happened. What you do with it is up to you. That's, the event needs to be obviously a business relevant, a business event. Okay, so that's one difference. This one for me is the hardest one, I think, to get my head around. But it's something that I think is kind of right at the heart of the difference. So since forever, I don't know about you guys, but at least for me, since forever, I've kind of looked for when I'm trying to design a system, I've looked at the data first, the nouns, and design things around that. That's how I learned to design object-oriented design, 30 years ago. And event-driven architecture is more action or verb-centric. And it does result in a different design. Is it right or wrong? I think time will tell. I think it depends. But I think in its purest form, it is really more, you look at the actions that your system can take versus the data that it holds. So the other thing is service. What's a service? So a service in a traditional architecture is something that you send a request to and it gives you a response. In an event-driven architecture, services are just things that consume events and do maybe have side effects and produce other events, right? And then here's kind of the hardest one, and I don't actually, I'd be curious to know if anyone actually does this, but I don't know of anyone that does. But in a pure event-driven architecture, the event streams are the source of truth. So, in theory, of course, if you record every event that ever happened, perpetually into the past, then you'd be able to rebuild any kind of state store. You'd be able to rebuild those state stores from that. I don't know how practical that is as a, as a pure strategy. I'm not sure how practical that is, but since we're just kind of trying to explore the difference, think about that. Event streams are the source of truth versus databases being the source of truth. So in the event-driven model, databases kind of go with their services. If you think about it, that's actually true for traditional microservices too. Databases go with their services. They're the representation of the data that service wants or needs. Okay, so, and they're built from event streams. All right, and then the other thing, I'll get to that last one. We're going to get to that last one later. The other thing are just interactions are synchronous versus asynchronous. So I have an example here. Let's talk through this example and kind of look at these principles. This is just, the example is based on order management because everybody knows it. Okay. All right. So we have a legacy system, and it's an order management system. It's got a database with hundreds of tables in it, and all the customer data is in there, all of the order data is in there, everything's in there, right? So we're going to embark on this microservices, event-driven microservices journey. And so the first thing we say is, I'd like to have an order service that that I carve out from this. So how would I do that? Well, okay, so remember, for agility's sake, I can't have that order service just pointing back at the database where the orders are now, because the whole premise here is like that database and that database schema are a point of coupling, and they're probably tightly controlled because any changes, rightly so, because any changes to the schema could break something. So you're supposed to get your own store. And that's even true whether that's traditional microservices or event-driven microservices. To get the benefit, you end up needing to have your own data store. And as someone that's worked in in-memory data grids, that's kind of, I've seen this a lot. All right, so how are we going? Okay, so let's talk about what's here right now. I've got a customer. I'm going to go ahead and, even though this is an event-driven microservice, I'm going to go ahead and put an API on it so that the shopping UI can call this API and place orders. Some things can be request response. It's okay. So I'll do that. And then when the order is placed, I'm going to publish an event onto a topic. Broker, Kafka topic, Red Panda, whatever it might be. and then other systems can do whatever they want with it, fulfillment systems, whatever. Okay, so, but how do I get this customer data out of here? Okay, so I'm gonna have to do something like change data capture, something like that. Basically, this is my first event stream. I'm gonna have an event stream that represents every single change to a customer record. And if you look at like one of the interesting books on this is just called Building Event-Driven Microservices. I'll have a reference to it at the end. It's an O'Reilly book. And it talks about this as liberating the data. So basically, if you're trying to go on this event-driven journey, and the assumption is your data is sitting somewhere right now, and you have to liberate it. You have to make it available to these event-driven systems. So, and usually you're going to have to do that through some form of change data capture. And this is, anyway, somehow or another, every time that data changes, you need to publish an event. And so that's what this is. And exactly how that works is that's a topic for a whole nother talk. Okay, but great. I've got my order service now. Here's another thing. I'm creating orders, and that legacy system had orders, and maybe there's reports. Maybe there are. For sure, there's reports. There's things that this order service doesn't handle. So how do I get that data back to the legacy system? Well, I have to write some adapter for the legacy system to consume those orders. So usually what customers do, and this is event-driven or traditional microservices, what they do is they kind of carve out a piece at a time. The whole point is to be able to do this gradually. Carve out a piece at a time, and so this is how you would do it in an event-driven system. All right, so I'm publishing orders. Now I can do other things with them. I'm going to write a new service. It's going to be the shipping service. It's going to subscribe to orders, and it's going to have side effects of actually causing the shipping to happen. But as the shipments progress through their life cycle, it's going to publish events to a shipments topic. Okay, and have a look. Notice this arrow here. So, in a pure microservices approach, each service needs to have its own data. Again, I don't want to go back to that legacy system. So, I talked about liberating the data. It's going to subscribe to the customer change data capture channel topic and build up its own data store. Okay. All right. Another thing that I wanted to so we talked about the different properties of event-driven services. So notice that these are actually verbs. So an order is, you might think of an order as a noun, but fundamentally it's an action customer placed an order, right? And shipping is an action. So I don't have a customer service here because customer is not an action. Okay, so there's that's kind of hints that kind of shows you some of the difference between a traditional microservices design and an event-driven microservices design. Okay, let's finish this up. So I think the last thing I would probably want to do is I would want to tell the customer. I would want to inform the customer. The business needs to know when things are shipped, but also does the customer. So let's have a notification service that again subscribes to customer data so that it can, for example, get the customer's address, whatever, and subscribes to shipments and it sends notifications. So that is an example of event-driven design. And let me go over a couple things, and then I want to hit the last point. I didn't plan to back out like this, so let's just go over a couple of things. So if we let's look at this list. So events-defined communication, that's pretty clear. So we published order events, we published customer data changed events, and we publish kind of shipping status events or shipping changed events. Action or verb-centric, we talked about that. Services consume and send events, that was clear throughout. And event streams are the source of truth. So the idea is that those event streams customer changes, orders, shipments, are those are the things that you can recreate the state of the business from. That's the idea. So that's why those are the source of truth. I personally am having a little bit of trouble just swallowing that one myself, but that is, again, like I think people usually do checkpointing and things like that. But I don't know. I'd be curious to hear if anyone I'd be curious to get your reaction to this architecture. Does anyone architect things like this? Any questions before we go on? Any questions or any comments? Yeah.
You mentioned in-memory database. Is that correct?
Yeah.
So is that part of this type of architecture? It wouldn't be a traditional, like each component wouldn't have its own database that's external, it's all in memory.
That since I've only worked for in-memory data grids for like 17 years, and yes, yeah, that's what they do with them. That's what I've seen a lot, and this is not limited to event-driven, but yeah, again, kind of getting back to, you have to have your own data store in order to be autonomous. Yeah, a lot of times an in-memory data grid ends up being the chosen data store. And a lot of times those products also have like file stores and things like that behind them, but yes is the answer. Okay, let's go on. All right, I wanted to talk about asynchronous versus synchronous. I've been involved in a lot of performance tuning, and so funny story. I was out with a friend the other night. This is actually a guy that I used to work at Turner Broadcasting with, and he just said, "What are you up to?" And I was working with a customer on performance of their system, and I told him that, and I said, "Yeah, I can't figure out why it doesn't use more CPU." And he thought that was a really funny way of looking at it, but actually, I can tell you, most of my so performance problems will broadly fall into two categories. One is it's just using up all the CPU, and you might profile it, you might be able to make it better, but that's almost a good problem, because if it was written in a scalable way, then that means what you could do is add hardware, and you can get more throughput. The harder problems are, like as I drive load, I get to a point where I can't process any more events, but the CPU isn't fully utilized at all. Happens a lot, and it tends to happen from, there's a lot of different things. Basically, you can have synchronization within the service, but one of the places it happens is a lot of kind of chained async calls. So I have an example to kind of illustrate it and make it kind of make it clear what's going on when you have microservices calling microservices in a synchronous way. All right, so here's my analogy. It's called the sneaky food truck. And the sneaky food truck here's their business model. You walk up to the counter, you place your order, and they actually dispatch somebody on a moped out the back door to a real restaurant. They have, that real restaurant has two chefs, they cook your order, they bring it back. And that's their business model. So let's look at how that runs. Some of this might, okay, I think that's big enough. Hopefully that's big enough. I'll narrate it anyway. All right, so here is Sneaky Food Truck Runbook version 1. Okay, so version 1, so we've got a couple of customers that we're trying to serve. We've got an order taker in the food truck, and then over in the diner we've got 2 cooks. So version 1 of the kind of operating manual is the order taker takes the order. He dispatches the order. The moped is over at the diner within a couple of minutes. Order's given to the first cook, and he cooks the meal. It's returned. Order taker packs it up and puts it in a bag or whatever, and gives it to customer 1. Turns around, takes customers 2 order. So basically, if you do the math, we end up taking 14 minutes per order. So now, when you look at this, what is the what improvement would you make to their business? How would you have them be more efficient? Yeah.
Give the order to the restaurant, then go back and get the second order.
Exactly.
And then pick up orders that are ready.
Exactly. So we don't, like, it's very easy. Okay, so it's very obvious in this scenario, right? But when sometimes we code systems, we code them exactly like this. And so here's a comparison. So exactly what you said, right? Place the order. Okay, notice, by the way, this is like the low CPU count. I'm going back to the first one now. I never even got both cooks cooking at the same time, right? Low CPU. All right, so now if I just simply dispatch the order, then turn around and immediately take the second customer's order. Take the first customer's order, dispatch it, immediately take the second customer's order, and then deal with the meals as they come back, package them up and hand them out. I'm going to have that second meal in the customer's hands at 16 minutes instead of 28 minutes. So I have much higher throughput because because I've gone async. The order taker in this plan, the order taker was calling things synchronously. In this plan, the order taker was calling things asynchronously. And so we do exactly that in big distributed systems, and you can see how compounded over A calls B, B calls C. You can see how compounded over a large amount of time this could be a problem. So one thing that the event-driven architecture has going for it is it's async from the ground up by design. Every interaction is asynchronous. So that's important for throughput. All right, so let's look at more of like the tech stack. How does that work? I've got three options here. So you're of course always going to need a message broker of some sort. Okay, and let's just assume you still also have some regular synchronous HTTP calls that you have to take care of. I don't think I've ever seen anyone that doesn't have some of both. So one way to do it is, so what's not going to change is the fast data store on the right and the message broker on the left. What's going to change is this app server in the middle. Where do we put those event processing logic? So one popular choice is in app servers. Okay. And we can do things, by the way, we can do things to make this faster. For example, all the in-memory data grids have like a local cache where, if you can afford a little bit of staleness of your data, you can have a copy of the data, 2 seconds old, whatever it might be, cached in your app server. So, but anyway, this is one choice. I would hazard a guess this might be the most common choice of architecture. Okay, let's look at the second choice. So there are these things called stream processors now, and they're designed from the ground up to process events. So one thing is, okay, let's use stream processors for processing events, and then let's still use app servers for processing regular HTTP request response type things. Everything else is the same. It's just that middle chunk. All right, and then option 3, which is an option I'm kind of interested in, is put everything in the stream processor. So instead of even having app servers, put everything in the stream processor. And I've got a demo of that to show you today. We're getting near the end of this part. I'm getting toward the part where we're going to do a demo. I've got a demo of that that I want to show you today. But the basic idea is you can regard a request, just a request, for service of any sort. You can regard that as an event, right? So make that one little shift, and you could process both kinds of workloads with basically one technology stack. So that one's interesting, and I have an example of it to show you in a little bit. Yeah.
So at what point does the topic become an event for a microservice?
Are you talking about if it's?
In the first box, an event, external event becomes a topic on the message book. Gets placed on the message book, right?
An event is.
Now, how does that become an event? Because it's event driven. So somebody has to wake up your microservice and say, I am here, do something for me, right?
Yeah. Now, I'll actually have an example of that, but stream processors, that's what they do. That's what they do. So their stream processors are like kind of written. You could think of it as backwards from kind of a regular microservice. Like when you say microservice, I think you're talking about something that traditionally might run inside of a Spring Boot app server. It's a function.
Is somebody sitting and calling the message broker, or is that interrupt driven? Somehow it's informing you. What is that, like an external library listening, or?
Okay, at this level we're talking about it. It's interrupt driven now. The ones I know about. What you're asking really fundamentally is actually inside the implementation of the stream processor. But the ones I know about, they use Java NIO library to do interrupt-driven I/O, non-blocking interrupt-driven I/O. So, but I'm not, that's Hazelcast because that's where I work. But I couldn't tell you that I would bet anything that Flink does it that way too. But I don't know. But anyway, the whole idea is that they don't sit around and wait for a request. They're coded in a way they're coded to handle events. Yeah. So, okay. All right, let's look at some of the specific technologies. This is guaranteed to be out of date, but I'll do my best here. If you've got other ones, shout them out. Okay, so you need a message broker. I think Kafka, there are various implementations of Kafka. There's Red Panda, Pulsar. You need something that's a true event log, that allows replay, that supports topics. And these are the most common ones I've seen. Okay, on this one it's a growing segment as well. You've got Kafka Streams, you've got Flink, and you have Hazelcast. You may not have known that Hazelcast does this, but it does. And then the fast data segment is even bigger. There's way more than two here, but I'll just list two that I know of: Redis and Hazelcast. I worked for a company. I worked for Pivotal, and they had Gemfire. There's a lot of these out there. So anyway, that's kind of the technology stack to put together an event-driven system. Anything else? Anything important that I missed? Okay, I'll keep going. All right, then Hazelcast in particular, because this is leading into the demo. Hazelcast in particular actually has aspects of all those integrated into one platform. So Hazelcast has some basic messaging. It's not a replacement for a message broker. I'll kind of make a better distinction in the demo, but has a full-featured stream processor and a fast data store that are integrated. So what it means is say that you're trying to process an order event and you need customer data. You're always going to need customer data, right? So I need to look that customer data up. Wouldn't it be nice if I didn't have to go out of process? So that is kind of one of Hazelcast's advantages. It's got this stream processor with the co-located fast data store. So you can go and get that customer is sitting in the same process, and it's able to do things like shard by customer and process the events, for customer X on the node where customer X's data is living, stuff like that. So that's a pretty cool capability. Now, it's demo time, so let me start explaining the demo that I have. Okay, so by the way, any questions before I go on to the demo? Yeah.
So how do you convert a timer-based applications into event-based? Maybe something needs to wake up and does something and go back to sleep. How do you change that to event-driven?
Okay, well, this is kind of detailed, but I have thought about that a lot. like Hazelcast, and I would bet anything Flink, it's the same thing, lets you write custom sources. So what I've thought about is actually just write a custom source that emits an event let's say it's every hour. It emits an event every hour. At a programmable time, it emits an event. And then that kicks off the processing.
But isn't it adding more complexity? Anyway, if you're writing a process to wake up every hour to do something, might as well do the job rather than creating an event.
Yeah, it depends. But if all your other logic is sitting in a stream process, and if all your other code is like event processing pipelines, oh, hey, and now I can do this one with an event processing pipeline. So that, yeah.
Yeah, we do that for purging. So there's a cron job that sends the message.
Okay.
And the purge happens just like for that, that fragment of the data. So we get better distribution.
So rather than doing the job itself, you just send a message to the
Although it runs like in the wee hours, right? 3 a.m. But it gives like a nice curve. You don't do all at the same time.
It also gives you just traceability and everything else that you can hook into the upstream that is decoupled and gives you access to all those benefits, which is great.
Okay, so it sounds like this is actually something that's being done in practice. Interesting, yeah. Anything else? I thought I saw one more. Maybe not. Okay. All right. Let me explain the demo. We've got plenty of time. I'm a little fast. All right. So this demo, the subject matter is monitoring machines. Okay. So telemetry from a factory floor needs to be summarized, combined with reference information about the machine, and then it needs to be made available as a HTTP service. Okay, and so there's two services here, and one's event-driven and one is traditional request response. And they're going to both be kind of incorporated into the same architecture. So the first one is just handle all those telemetry events off the machines, summarize them. So like I would like to know the average bit temperature over the last 5 minutes. Average it out over the last 5 minutes for this machine. Okay. So that's service number one. Service number two. I want to be able to check that information. I also want to kind of line it up with data about the machine. So this machine, this model with these settings, what is the kind of inbounds and out of bounds range for that metric? When is the bit temperature too high? When is it too low? Whatever. So that could be that could be specific to the machine and the machine setup. So I want to look that up, and so I'm not getting just okay. It's 105 degrees. I want to go. It's 105 degrees, and that's nominal for this. That's nominal for this machine set up this way. So that's service 2. Okay. So the architecture looks like this. It's all hosted. Well, not all of it. It's hosted. Most of it's hosted in Hazelcast. So the telemetry lands in a message broker. I chose Red Panda. So telemetry lands in a message broker in a topic. So one pipeline, this one here, consumes that, and it produces it. Actually, I think I have an arrow going the wrong way here, but one pipeline consumes that and writes the summary. And then the other pipeline is fed by a traditional request response service, and what I've done is just write a bridge. So basically, you hit, and I used this is a Spring Boot app, and I used all the Spring Boot async APIs so that even this interaction here is not it's not synchronous, it's not blocking. So basically, caller calls this service, but this service is a thin shell. The shell sends an event into a basically request topic, and then the pipeline computes the answer, and it sends the event back into the response topic, and then that is returned to the client. That raises an event in this HTTP bridge, and that's returned to the client. Okay, why? Okay, so doing it this way allows me to handle kind of both kinds of workload with the same basically stream processor, basically with the same architecture, same tech stack, right? The other thing is what I mentioned earlier about event-driven architectures being async from, so this thing is asynchronous from end to end, so it scales really well. It's, the more load you throw at it, the more CPU it'll use, which is what you want. Nothing blocks. Okay, and it's low latency because I'm taking out hops. So I don't have to, so in this example, when an event comes in, I need to go look up the valid range for the metric for that machine. So if I have to, even a remote hop, even to a fast cache, like whatever it is that's not local, is, it's probably at least a couple milliseconds. Do that if you're trying to do 1,000 events a second, that starts to add up. So having this is where having the data, the kind of enhancement data co-located in that in-memory data grid is useful. And then the bonus, which is really interesting, is blue-green deployments and a lot of flexibility in general. So let me explain. So here's the idea. You basically can use different topics for different versions of the implementation, right? So I can have one pipeline that's the version A or the blue, second pipeline that's the green. That's so like, I developed the blue and now I'm going to deploy the green, and or you could do canary style deployments. So basically, there's nothing keeping you from having two pipelines running that both service that request, and then just with a little bit of smarts in the this part here, it can dispatch to one or the other according to your instructions. So they're both out there. Just so you think about it, like you've got your blue and your green. They're both sitting out there. They're ready to receive events, and then you can just very easily swap, kind of route events to one or the other or both, just with some simple instructions. So I thought that was a cool bonus. I know there's other ways to get that as well, but this is just a little detail on how that works, and then I'll actually fire up the demo.
Excuse me. I got a question about the pipeline. Can you zoom in on that a little bit and talk to what is it Lambda? Is it
Yeah.
representing using an interface that?
Okay. Have you used Flink by any chance? Okay. So both. Okay, I know a little bit about Flink and a good deal about Hazelcast. And fundamentally, what they're both doing is you're assembling a graph of steps, and you provide the code for each step. But then that graph is kind of I don't have slides for this, but that graph is kind of replicated and run across the whole grid, and it can be done in a smart way, like so that there's data affinity and things like that. But basically, you say something like, I can actually show you the pipeline for Hazelcast when we get to it.
It's not a Spring Boot app. I could have thought I heard you say Spring Boot app. That's what it means.
It's not a Spring Boot app. It's just a Java jar. In this case of this demo, it's implementing Hazelcast pipelines. Hazelcast pipelines are heavily functional. They use a lot of lambdas, and because I heard you say both of these things, and Flink actually uses a lot of, in the Java implementation of Flink, it actually does use interfaces like a couple of the verbs in the graph of steps would be like filter and map. A map is just a transform, right? And so with Hazelcast, you'd provide a lambda for the filter and a lambda for the map. With Flink, I think they actually have interfaces to implement. Like this is a Flink filter node, and it returns a true or a false. So when you give it an event and like that. So But the basic idea is I'm going to describe this graph of steps. Could just be one step, but I'm going to describe this graph of steps, and then the stream processor is going to run it for me, hopefully in a smart way, distributed, definitely in a distributed way. So we can look at the code when we get to that point. Any other? Yeah. Okay. All right. Moving on. All right. Detail about blue-green deployment. Okay. So the way that it works in the demo is basically this web service proxy has a copy of some routing information, and you just tell it. So Hazelcast maps can act like topics. Again, not a full replacement for a Kafka topic, but for this purpose, it's actually perfect. So you just tell it, okay, so even though I said map here, think topic. So you just tell it, hey, send 50% of the request to the V1 topic, send 50% of the request to the V2 topic. V1 is served by one pipeline, V2 is served by another pipeline. And I can deploy those pipelines dynamically, and then I can just basically update the routing information to control the flow of events to one or the other. So that's a setup for the demo. Here's a more complete technical architecture of the demo. All the different parts. This is all just going to be running on my laptop. So the machine, the events down here that I have down here, these are the machine events. Those go to a red panda topic, and then running in the grid, there's a pipeline whose job is, it's got these steps. This is that graph I was talking about. There's a pipeline whose job is to basically just do a 10-second tumbling average by serial number. So for every machine, just constantly compute 10-second average of a bit temperature. And then put that in a map that's in memory. That's what that does. And then this other pipeline is meant to serve requests. So it basically, whenever a request comes in, it reads it. It retrieves those aggregates from that map, which it's co-located with. It also goes and retrieves machine profile data so that it can basically tell you whether that's a value that's okay or not okay. And then it writes the response back. That eventually goes back to the caller, and the caller is provided with the response in the form of an event. All right. So that is the technical architecture. Let me see if I think that's pretty much it. Any questions about that? All right. Let's go on. I'm right at 45 minutes. That's pretty good. That's decent. Okay. So let me see where I had this. It's all running in Docker Compose. All right, so hopefully that all worked. Let's have a look. So first thing I should have. So this is a kind of a UI for Kafka. I really like it actually. It's really nice. So I mentioned I have a red panda. Yeah. Okay. Submit. There we go. Okay. So I have a red panda Kafka broker. One of its topics are machine events. We can see that messages are actually flowing. If I look here, there, we can see the messages are actually flowing. The key is the serial number of the machine. That's this here. And then the messages are in JSON format. So there's the messages. Now let's look at, let's make sure that the service is actually up and running. So I'm going to, here, let's stop the live mode here and let me pick one of these. So I'll pick like NAQ 165. Let's pick that one. All right, so there's supposed to be a web service where I can request the status of NAQ 165. I'm going to move everything to the same window here, or the same desktop. Oh, I missed it. Where'd it go? Okay, there we go. All right, so this is Postman. Okay, so now I forgot my. Let's just send it and see. Yep, no, I didn't forget it. Okay. All right, so there's everybody familiar with Postman? Postman is hitting. Yep. Okay, so use it for regular web service testing. So this is hitting a web service that's running. That's running in Docker. Or I guess I could show you this as well. Let me look at the Docker dashboard. What all is running? All right, so inside of stream processing fundamentals, we have a Kafka UI, a ref data loader that's already done its job, a few kind of setup steps. Then the status service, that's the web service, a performance test that I'm going to show you, Red Panda, a couple of Hazelcast nodes, a Hazelcast Management Center, and an event generator to generate the events. So that's all just running on my laptop. Okay, so just ask questions if you get lost because there's a lot of parts to this. Okay, so we got events flowing. We got a web service that's exposing the events. How is that working? So let's look at the Hazelcast UI. Okay. All right. So this is the Hazelcast user interface. So we won't go over the whole thing, but the main, just a couple things to notice. Okay. It's a cluster. It's composed of a couple of different nodes, and it's got maps. So, for example, there is a lot of these maps can be accessed by SQL. So, so for example, let's see. I think there's one called machine profiles. This is in a map in memory loaded by the reference data loader. There's the serial number and then some facts about the machine, okay? So, but what I wanted to show you was the pipelines that are processing the events. So the requests are coming in. Okay, there's this request map with one entry. The requests are coming in. There's a response map with one entry. Those are the request and the response for that one time I ran it. If I run it again, it will, it should show up as a second. It may take a second to update, but it should show up as a second one there. And then, yeah, there they go. And then there are these jobs, and these jobs are these event processing jobs. And I mentioned that there's two. One is taking care of the aggregation, right? And so you can see here that this is aggregating, and there's more items in than out because it's aggregating. So it's like computing 10-second windows. So every 10 seconds it goes, okay, here's the average for this serial number. Here's the average for that serial number. And then there's the status service. And you can also see here that the status service is so far processed. For the status service, an item in is a request and an item out's a response. So it's processed too. So that's kind of all the pieces. Now, I did want to also show you, before I start changing the routing information or anything, I wanted to run a performance test. So all these ports, can I remember them? I think it's 8089, there we go. So this is Locust. I don't know if anyone's used this. I actually think this is awesome for web service performance testing. You used it? Yeah. Yeah, I love this thing. So I'll do, 50 users, 2. I think it's called status service. I think the port's 8080. Let's see if this is correct. There we go. Okay. So it's generating load right now. It's measuring all these things, the response times, min, max, and various percentiles. Give us a nice chart it shows us the response times. Okay, so now the system's under load, and if we look, and we can see, there's some load. It's not overwhelming, but yeah, there's some load, and we can see. We look now at these two jobs. Now the status service 1 is handling a lot more items, right? Okay, so I wanted to show you the blue-green part now. So let's deploy another pipeline. So I have have to go and find the name of the job that deploys the new pipeline. Submit summary service job 2. Okay. All right, so all that's going to do is deploy a new pipeline. I'm going to go back over here. Should see a new pipeline popping up, assuming it all worked. Yeah, it worked. There you go. So I got a new pipeline that's popped up. It hasn't processed any events because I haven't updated the routing information. So like now I've deployed the newer version of my microservice. I want to cut traffic over. I'll say I just want to go 100%, but I want to be able to cut it back as well. All right. So preview. How are we going to even know if there was something different? So the first service that I deployed didn't calculate. First service I deployed didn't calculate. It didn't do any lookups. It didn't calculate the status. Red, green, orange, whatever. It just reports the bit temperature, and that's it. Okay. So all right. So the second service is an enhancement. It actually does the lookups and stuff like that. So it's deployed, but it's not taking traffic yet. So I can swap the traffic over. This is effectively, I'm just updating a map, but I have a script to do it. So I need to go and look and remember what I named that. Just a second. That would be called load routing config 2. There we go. Okay. So that just basically is a program that updates a map that contains the routing configuration. So now that's been updated. You can see immediately the status service 2 is picking up events, and I've gotten my blue-green deployment. You can tell that it's a different service now because it's actually doing some lookups for me, right? So was service interrupted at all? Well, I can go over here and I can see it doesn't really look like you can't really see any interruptions of throughput or latency. And if you look at the stats, there's no failures. So it just cut over without any problems. And we can actually undo that too. Like say you do see a problem, you want to roll it back, right? So I'll put the other config back in, and suddenly this one should stop taking traffic, and this one should start taking traffic. Let's see. Yeah, so there you go. And if I look at my microservice, if I look at my Postman output, send the same request, it's back to the original one. So. And no interruption there in the, no failures. And there we go. Look at that. There you go. No failures. So that's the demo that I wanted to show you, hopefully give you an idea of how you could do kind of a pure event-driven architecture, and hopefully gave you some food for thought about event-driven architecture in general. Any questions? If you want to look at the pipeline, I can show you that. Yeah.
So how do you do troubleshooting or debugging? Like you have two versions of services, and where did you find out the log, or where did you find out where a particular event is processed by which version of your service?
So I think the right answer to that is actually it is a weakness of event-driven architectures in general. It can be hard. you know, like a couple of things that occur to me, but I think it's fundamentally, I think it's something that's maybe harder in event-driven architectures, at least what I've seen. Also interested in everybody's opinion on this, but I think it's harder. You would have a record of because there were like the specific question you asked. I actually can save the request and the response, and there's that correlation ID. So I can actually see. So like here, I can actually see, you know, if a request was serviced by version 1 or version 2, and I can actually see the corresponding result, and I can just choose to keep those around as long as I want. So that's a little bit of a help. To be honest, when I write pipelines, the best thing is to do a lot of debugging locally before you deploy it. But once you deploy it, I think it's kind of a weak spot, you know, in the industry. It's something that still needs to mature, I think. So, yeah.
Hazelcast, you said these maps are these queues or topics or the hash tables are technically what?
These are all maps.
These are the hash maps,
Java maps. So one of the things that Hazelcast did that you might not be aware of is that remember I said maps can act a little bit like a topic. So there's a configuration. If you turn it on, every change that you make to the map will go into a journal, and so basically that becomes an event journal. And there's even some use cases where we don't even care exactly what's in the map. We only care about the event journal. So, yeah. This is all in memory. So, yes, Hazel. That's my email. That's not what I wanted to show you. Hold on. I was trying to go find the slide deck. Where did I put that? There it is. That is why I architected it this way, because I think that so for these requests and responses, like they don't have to stick around forever. They're just, you don't have to record, you don't have to remember that that this was called 15 times. So map journals that's the Hazelcast feature. Map journals, perfect for that. For actually being a record of events that, the record of events, you should use like a proper broker.
Can we replace this with Kafka? Since this is
Yeah. So like I use Red Panda for this, and yeah, I could have replaced this bit here. I could have just taken these and made these topics. I could have done that. It would work. So since I didn't need to keep them around, and this way it lets the event be co-located with the stream processor and the map data. That's why I did it that way. Yeah. Yes.
Can you touch on this? What's your opinion on Avro versus JSON for messages?
I don't have a strong opinion on that. I really don't. The only opinion I have is that you need a. Okay, so I said earlier that in traditional microservices, the API is the interface. Like we need to design our interface. We don't want to be back where we started with a kind of ill-defined interface in the form of a database schema. So we need a schema. That to me, that's all I care about. Not an expert. I would bet that Avro performs better, but that's But as long as you have a schema, I feel like that meets the requirements for an event-driven system. Yeah, because that's the interface. The event's the interface, so you got to have a schema. Yeah. Anything else?
Do you know if Kinesis is getting any traction?
That's Amazon's managed service. What's underneath Kinesis? Is it their own thing or? Yeah. No, I don't know the answer. I don't know. Yeah, I don't know. I bet it is because it's it's an easy to use. I think people are generally climbing the ladder and trying to use higher level managed services. So I bet it is, but I don't have any specific information.
Is underneath?
Yeah. know. Maybe someone else here might know. I don't know.
Do you ask about DynamoDB?
No, Kinesis.
Oh, Kinesis. Yes. Kinesis is not based on like Apache Kafka or Pulse or anything. It's their own proprietary technology.
Yeah, no, I was just curious if it was like getting any traction.
It is. There are a lot of people that use it.
Yeah. All right, anything else?
Well,
Thanks.
folks, thank you for coming, and let's give it a round of applause.
Thanks, guys.